What is up, team? I am the Masters Math Teacher. In this video, we are starting a new topic, the world of polynomials. So jump on board and let's get into it. Now in this video, it's going to be a little bit shorter because we're going to focus solely on the lingo and notation used in this section. If you think you already understand the keywords, you can skip this video and move on to the nitty-gritty stuff in the next videos. So you might have heard of polynomials before, and in fact you've actually worked with them quite a lot when you were doing parabolas. So first let's see the definition so we can see why. So a polynomial function can be written in the form a(n) x to the power of n plus a(n minus 1) x to the power of n minus 1 ... Then we're dealing with a2 x squared a1 x1 or just x plus a0. Okay, so what does that mean? There's a lot of symbols, a lot of letters, but what does it actually mean? So let's take a look at this function here, 3x squared plus x plus 4. So what we can see here is this 3 is our a2 because it's the coefficient in front of x squared. Our a1 is like 1, so that's a1x, and our constant, or our a0, is 4. So all we're saying is any function or any equation that can be written in the form coefficient x to the power of something, coefficient x to the next power of something, etc., down to a constant is called a polynomial. Now the letter does not have to be x, it can be other letters, however usually we are dealing with the letter x. So let's look at another example of a polynomial. Let's take 7x to the power of 6 plus 3x to the power of 4 minus 2x take 8. This is also a polynomial. We've got a6, which is 7, because it's the coefficient of x to the 6. But what about a5? Well, there is no power of x to the 5 here. So it's actually 0. Okay, so this means this is still a polynomial, even though we skipped that term. We've got a4, x4, so a4 in this case would be 3. Then we've got another a3, x3, and of course that must also be 0 because there's no a3 here. There's no x cubed term. There's also no x squared term, in which case a2 is also 0. a1 in this case would actually be -2, so we've got to include the symbol as well. And our constant a0 is going to be our -8, again including the symbol. Okay, so let's take a look at some lingo here. The first bit of lingo is the leading term of a polynomial. Okay, so a leading term. So when we're thinking about leading, we think of the thing in front. So the leading term of this polynomial is the term with the highest power. Okay, so if we ordered our polynomial the same way as we did up here right at the start, with our highest power of x first and our lowest power of x at the bottom going down, the first term, or the term with the highest power of x, is our leading term. So it is the term with the highest power of x. Okay, so our leading term of our blue equation, I'll highlight it in blue so that we can really identify the difference. Our leading term here is going to be 3x squared. Okay, that is our leading term. In our green equation, the leading term is again our first one, 7x to the 6. Now, it might not always be the first one. What if I wrote this equation, the green equation again, as 3x to the 4 plus 7x to the 6, take 2x, take 8. Now we can see this equation is still the same as the green. They're actually the exact same equation. All I did was switch the 3x to the 4 and the 7x to the 6. But the leading term is still 7x to the 6. This is still the leading term because it is the highest power of x. Okay, the next bit of lingo. That is the degree of a polynomial. It's the degree of a polynomial. The degree of a polynomial is just what is the highest power of x. So the leading term, that was the whole term, so 3x squared or 7x to the 6. The degree is just the highest power. So what is the highest power? So let's look at our blue equation. Our highest power is 2. So this one has a degree of 2. For our green one, it has a degree of 6. Okay, even if we were looking at the green one in the bottom here, this still has a degree of 6 because it's with the highest power of x, not the first one. I'm going to briefly cover the next bits because they're not as important. However, it's still nice to note what they mean. So a monic polynomial. A monic polynomial is something with the leading term that has a coefficient of 1. Okay, so if the coefficient of the leading term, that links back to our definition of leading term up there, is 1. Okay, so neither the blue nor the green are monic polynomials. However, let's write something like this. If we go with x to the 5 plus 3x squared plus 2, this is a monic polynomial because our leading term has a coefficient of 1. So that's what a monic polynomial is. And the final piece of information, or the final piece of lingo, is what is the constant term? Now, hopefully you've heard of the constant term before, but it's just which value in this equation does not have an x. So if we look at our blue, it's 4. It's the constant term, the bit with no x. In our green one, it's -8, the one with no x. So this is our constant. If we're looking at the general formula for a polynomial, it's the a0 term. It's the term with no x. The term with no variable. And I'm writing variable over x because we don't have to use the letter x. It can be a different letter. Okay, the last bit of stuff I want to cover in this video is about how to use the notation correctly. Now, with a polynomial, we actually use very similar notation as we do in functions. What we do is we call it p of x. Okay, so if I was doing that blue one above, I can say p of x equals 3x squared plus x plus 4. Okay. Same thing as our functions. The only difference is that we tend to use letters like p and q rather than f and g, just because they're polynomials. It has no impact though. Remember with functions, if I wanted to find what is the value of this polynomial when x equals 2, that's the same as saying p of 2. Okay, and sure enough, that just means I sub in 2 where there's an x. So p of 2 equals 3, 2 squared plus 2 plus 4. So 3 times 4 plus 6, just grouping those two. 12 plus 6, and we get 18. Okay, so that's how we use this notation. It's the same way as we did with functions. We're just using different letters, so we tend to use P or Q. So that's it for the lingo of polynomials. I hope this helps you understand some of the funky words that'll come up in this section. I'd wish you luck, but I know you don't need it. Go smash out some mathematics. And as always, if you liked this video, give it a like. If you didn't, give it a dislike. And let me know in the comments what I can do better. If you have a topic you want me to cover, let me know in the comments below.